in this problem, we want to design a finite state machine that detects a particular sequence. So what we want to write is a machine that detects the sequence of inputs of 1, 0, 1, 0, 1, 0. So you have someone who is giving inputs, and the finite state machine is watching, and when it has had this as an input, then at that point it gives an output of 1. Otherwise, it gives an output of 0. Okay, so and there's a couple things that you would want to know. So you would need to know, is it supposed to output 1 when it gets the input that makes this string, or on the next clock cycle? So that is one thing that you'd want to know. Another thing that you would want to know is, should it detect overlapping strings? So for example, let's say this was your input. So you had the string right here, you detect that, but then you have that same string again right here. Are you counting those? Do those count as separate hits? Are those both detections? And so on this particular one, we are going to say that when you get the 6 signals in a row, on the next clock cycle, the output is 1. So that tells us that our output does not depend on the current input. The output depends on what state you're in at the time. So this tells us we're going to be building a Moore machine. Now, it could go either way. It depends on what your directions are. And then we are going to allow, it should detect overlaps. So we need to figure out what our states are. So you always start with saying that you don't have anything. It's like when you start, you have not advanced any towards getting your sequence. What I mean by that is, let's say that you have 1, 0, 1, 0. Well, you've advanced towards getting your sequence, so you're in good shape. But on the next one, if you get a 0, well, you're out of luck. You're all the way back to square 1. And so at different points along the way, you are advancing towards getting your sequence. We need to have 7 states in our machine, accounting for if I'm at this state, or 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 at this state, towards getting to my sequence. So I start with what your professor likes to call got zip. You don't have anything. You are not anywhere along the way towards getting your sequence. If you are at that state and you get a 0, you're no better off than you were before. You still got nothing. But if you get a 1, then now you have the first bit in your sequence. So you're on your way. Now what happens after this if you get a 0? So got 1. So if you get a 0, you now have the first 2 bits of your sequence. But let's say you're at 1 and you get a 1. Are you all the way back to got zip? No, because you still have a 1. You still have the first bit of your sequence. So if you get a 1, you go back to this state. Now let's say you're at 1, 0. So now you have a 1, 0. and the next bit you get is a 0. Well, that's no good. Now you got nothing. You're all the way back here. But if you get a 1, we have now advanced, and now we have 1, 0, 1, so we're in good shape. Now, what happens if we get a 1 again? So if we get a 1 again, we're at 1, 0, 1, 1. Well, the only thing we have towards our sequence is that single 1. So that's going to take us back to this state right here. But if we get a 0, then we'll advance to the next state, and we'll have 1, 0, 1, 0. From 1, 0, 1, 0, if we get a 1, we are at the next state in our sequence. But if we get a 0, so if we had 1, 0, 1, 0, 0, we got nothing. We're all the way back here. Now from this state, if we get a 0, we're almost, we are there. Yep, we're there. Okay, so that's it. So this is good. This means on our next output, we can output a 1. On all of these, our output is 0 because we have not yet achieved the sequence that we want. But on this one, our output is going to be 1. And not only that, if we get a 1 on our next sequence, so if I have 1, 0, 1, 0, 1, 0, 1, then where I am is I have 1, 0, 1, 0, 1. I have the first 5 bits, so this would take me back to this one if I get a 1, but if I get a 0, I go back to the beginning, and I think that's everything. So now that I have this, I'm going to want to draw a state table. So I've got my state diagram. Now I want to do a state table. And I'll label these states A, B, C, D, E, F, G. And notice I have 7 states, 1, 2, 3, 4, 5, 6, 7. And so present state, next state, output, and I'll have a different next state if W equals 0 or W equals 1. The output does not depend on the input. So this would be A, B, C, D, E, F, G. And the only one that gets an output of 1 is G. Everybody else has an output of 0. And for A, my next state, if W was 0, was A. And if W was 1, it was B. And for B if my next state was 0, it was C. And if my next state was 1, I was back to B. And for C, if I got a 0, I went back to A. And if I got a 1, I went to D. And for D, if I got a 0, I went back to. If I got a 0, I went to E. And if I got a 1, I went to B. And for E, if I got a 0, I went back to A. And if I got a 1, I went to F. And for F, if I got a 0, I went to G. And did I not do if I got a 1 for F? I don't think I did. 1, 0, 1. No, I'm sure I did. 1, 0, 1, 0, 1. And if I got a 1, no, I guess I didn't. If I got a 1 from this one, that takes me back to having just 1, 1. So that would take me back to B. And for G, if I get a 0, that took me back to A. And if I got a 1, that took me back to F. Okay, so now my next job is to decide how I want to assign these states. I have 7 states, so 7 is less than 8, but it's greater than 4. And this is 2 squared, and this is 2 to the 3rd. And so I need to have, since 7 is greater than 4, I need to have 3 flip-flops. Since it's less than or equal to 8, I don't need more than 3. So I need 3 flip-flops, which means 3 variables. So I now can assign these. So I take this same table, and I'm going to assign binary numbers to these. So I'll do 0, 1, 2, 3, 4, 5, 6. You have freedom, unless you're told something different, to design them, to make them something different. And I'm not going to put in the output column because it's so easy. It's just zeros and then 1. And so 0, so A is 0, B is 1, C is 2, D is 3, E is 4, F is 5, and G is 6. You'll notice I'm not using all of my possibilities, so I'm going to put in a 1, 1, 1, and I'm going to put that one in as don't cares, because I'm not expecting to use that one. So we have now assigned our states this way. And so I will use those same state assignments to fill in my next state. So everywhere I have an A, I'll put a 0, 0, 0. And wherever I have a B, I'll have a 0, 0, 1. And a C will be 0, 1, 0. And D is 0, 1, 1. And E is 1, 0, 0. F is 1, 0, 1. And G is 1, 1, 0. And I'm going to pause for a minute and check my work and make sure everything is correct. Okay, everything looks good. It's kind of a surprise the way I do things. So I'm not going to derive the circuits for all 3 flip-flops, but we'll do one of them and see how that works. So we'll do Y2. So Y2, we want to do a Carnot map, and our Carnot map will have 4 variables. It will have Y2, Y1, and Y0 and W. 0, 0, 0, 1, 1, 1, 1, 0. 0, 0, 0, 1, 1, 1, 1, 0. And I'll start with the W. Did I say which one I was doing? I don't know if I said which one I was doing. I'll do Y2. Capital Y2. And I'll start with when W is 0. So W is 0 in this top row and the bottom row. So Y2, Y1, Y0, 0, 0. Well, I'm just going to look at the ones that have 1s. So the ones that have 1s are Y2, Y1, Y0 equals 0, 1, 1. And Y2, Y1, Y0 equals 1, 0, 1. And both of those were with W equals 0. So Y2, Y1 is 0, 1, and Y0 is 1, and W is 0 is right here. So that's this one. And then this one, Y2, Y1 is 1, 0, and W is 0 is right here. And now I'll look in this column. The only 2 places I have 1s are in the state E and the state G. So this is when Y2, Y1, Y0 equals 1, 0, 0, and Y2, Y1, Y0 equals 1, 1, 0, and in my second column W equals 1. So Y2, Y1 is 1, 0, so that's this column right here, and W equals 1. Oh, and so Y2, Y1 is 1, 0. Y0 is 0. and W equals 1 is right here. Y2, Y1 is 1, 1 is this column. Y0 is 0, that's up here. And W is 1 is right here. So it looks like my Carnot map. Oh wait, I have my don't cares. I need to put my don't cares in. My don't cares are at 1, 1, 1. And so 1, 1, 1, so don't care, don't care. And I think I have a mistake. Okay, so looking at this one right here, Y2, so I'm just going to go through each one and see where I messed up. So Y2, Y1, Y0, that's equals, so first I was looking at this one right here. So I'm looking for a Y2 is 1. Y2 was 1 right here, and it was 1 when Y2, Y1, Y0 was 0, 1, 1, and W was 0. So Y2, Y1, 0, 1 is right here. Y0 is 1, means that's these two right here. And W is 0 is right here, so that's this one. So this one is correct. Y2, Y1, Y0 is 1, 0, 1. That comes from this one right here. And W is 0. So Y2, Y1 is 1, 0. Y0 is 1, so I've messed up somewhere here. And W is 0. So that's this one right here, and I think I put it in up there by accident. But we'll check and see. So then we have the ones over here. Those correspond to these values. So this one happens when Y2, Y1, Y0 is 1, 0, 0, and W is 1. And this one when Y2, Y1, Y0 is 1, 1, 0, and W is 1. So Y2, Y1 is 1, 0. That's this column right here. Y0 is 0. So that's one of these two, and W is 1. That's right here. So this one is good. And Y2, Y1 is 1, 1. And Y0 is 0. That's one of these. And W is 1 is right here. So that's, I think, is right. So, yeah, I think this one is right now. So the best way to cover these is to get those two together, and these two together, and these two, because I can use those don't cares. So Y2 equals these two right here, those two, have Y2 equal to 1, Y0 is 0, and W is 1. This group has Y2 equal to 1, and Y0 equal to 1, and W equal to 0. And our last group right here has Y1 equal to 1, Y0 equal to 1, and W equal to 0. So let me check that and see if that matches. So Y2, Y0 bar, W, Y1, Y0 W bar, y2, y zero, I forgot to put the 0 in, W bar. Okay, so then if I wanted to make this into a circuit, I could have a slightly cheaper circuit if out of these two I factor out that W bar. Actually, I can factor out a Y0 W bar. And I have Y2 or Y1 left. You have to go? Okay, so I'm going to just finish this problem up. Okay, so now let me draw this. So this, I will have my 3 flip-flops. My 3 flip-flops will be corresponding to capital Y0, Y1, and Y2. So I have Y, well, I'll have Y0, I'll have that be D0, I have Y1, and that'll be D1, and Y2, and that will be D2. And so these, so I have, so, and this is my input for Y2. So this right here is my input for Y2. And I've got a lot going on. So I've got an OR gate. My last thing here is an OR gate. And into that OR gate, I'll do this top one first. That's an AND. It's an AND of Y2. So that's coming around from here. Y0 bar and W, which is my input. And then my other input into the OR gate is also an AND. And it's an AND of two things. It's an AND of an AND of an OR. And the OR is Y2 or Y1. So this is Y2 right here, and Y1. And the AND is W0 and Y0. This was Y0.